Okay, this is the the summer review 1 worksheet, and these are the problems. Start with number 1, and we have these complex fractions. We deal with these a lot in calculus, and we just have to simplify these. That was the direction. And remember, we don't want any values of the variable that will give a 0 in the denominator, so you have to put restrictions on your domain because of that. So when you see here, you have an x plus 2 in the denominator. That denominator can be 0 when x is negative 2, so you can't have that. And then this denominator will be 0 when x is negative 3. So those are restrictions that we'll have to apply at the end of the problem. The easiest way to do this is a shortcut. And we talked about this before in some of the other problems. You know, sometimes you can try to get one fraction at the top, one fraction at the bottom. But because we do so many of these in calculus, we take a shortcut. We just multiply the top and the bottom of the complex fraction. Now remember, a fraction is a complex fraction if you have a fraction in the numerator, the denominator, or both of a fraction. So we have a fraction in the numerator of this fraction, the top right there. So we have a complex fraction, and the easiest way to get rid of the complex fraction is multiply the top and the bottom by the least common denominator of all the denominators of any fractions you see in the top or the bottom. So we just have this x plus 3, so that's the only denominator we see, so we multiply the top and the bottom by x plus 3. And in one step, that gets rid of the complex fraction. Now when I multiply this, I just have x times x plus 3 minus, and then these x plus 3's cancel, so I just x. And at the bottom I've got x plus 2 times x plus 3. And then I'm ready to simplify the top and combine like terms. So this is x squared plus 3x minus x. So I'll just multiply this out. Let me take this off here so it's not so obtuse. And then I can simplify 3x minus 1x is x, so there's your final answer. You could factor out the x if you wanted to. Oh, that wasn't your final answer, because you could factor out the x, and if you did, you had x times x plus 2 over x plus 2 times x plus 3, so you have a common factor here of x plus 2, so you can cancel those out. So now you have x over x plus 3, so that's your final answer. Pardon me. All right, now in some of these problems they ask you to put the restrictions on the domain, and some they didn't on some of the answer sheets, so it's a little inconsistent, but I try to put them in on most of them. But in this case we would just have to say x is not equal to negative 2 and x is not equal to negative 3, because that would give us zeros in denominators here and here. Okay, so I hope that makes sense. Let's try the next one, number 2. And again, I work these out, give a little space because it saves a little bit of time, because it takes a little bit of time to download these videos if they're real long. So I kind of worked them out already. So x minus 3 over x minus 3 over x minus 2. So this is the fraction that makes it a complex fraction. So that's my only denominator, x minus 2. I've got a fraction in the denominator, not the numerator. All right, remember, numerator is the top, denominator is the bottom, ND. Yeah, I remember that by saying Notre Dame. Okay, numerator, denominator. All right, so I have a fraction in the denominator, and only one denominator there, x minus 2, so that's my least common denominator of all the denominators I see, so I multiply the top and the bottom by x minus 2. And on the top I've got x minus 3 times x minus 2, and on the bottom I've got x times x minus 2, and then these cancel, minus 3. And then I multiply this out, so I get x squared minus 2x minus 3. And then again, I want to make sure that this is factorable. When I simplify this, remember, x squared minus 2x minus 3. And I see if I can factor this, and I could factor this. This was another simple trinomial. So it factors to be x minus 3. That's how I get the negative 3 times x plus 1. And you always multiply these out. X squared minus 3x plus 1 is minus 2x, negative 3. There we go, checks out. And again, I've got a common denominator of x negative 3, x minus 3, so those cancel. Now, the only reason why they would cancel because x cannot be 3, because 0 over 0 doesn't work. So we can't have that 0 in the denominator. So again, after we cancel these, we have x minus 2 over x plus 1. And any time in the problem where we're going to have a 0 in the denominator, we've got to restrict that. So here we had x minus 2 in the denominator, so x can't be 2, x can't be 3, and x can't be negative 1. So those are the restrictions on the domain. So at no time I will have 0 in the denominator. Okay. So I hope that makes sense. I think I've worked these out step by step, so they should be easy to follow. And we'll try one more. Now this is a little bit more interesting. Now you really have to know how to factor and be aware of all these factoring methods, because if we look over here, we can pretty much identify this. This is when you should know by now that this is just the difference of perfect squares. So this is basically x minus 2 times x plus 2 right here. So those are basically the same. Now I have a pretty good complex fraction because I've got fractions in the top and fractions in the bottom. And the least common denominator of all three fractions would be x squared minus 4. Now I can write that either as this or this. So I chose to write it as x plus 2 times x minus 2. So that's my LCD. So I multiply the top and the bottom by the LCD. Okay, so when we do this, the x minus 2's cancel. When I'm talking about just the numerator. The x minus 2's that cancel. So I've got 3 times x plus 2. And in this fraction, the x plus 2's cancel. And I've got negative 4 times x minus 2. Now remember, be careful with this negative sign, so don't forget that. So I've got nice parentheses here to remind me of that. And then when I multiply this, remember x squared minus 4 is the same thing as this, so this completely cancels with that, cancels out that denominator. So these cancel out, so I just have 7 over 1, or just 7. So that denominator cleaned up really nice. Okay, then I just can multiply out my numerator, because I know I'm going to be able to combine like terms here. So I got 3x plus 6 minus 4x, and remember, a negative times a negative is a positive 8. That's kind of a mistake. Sometimes students forget that second term. All right, all over 7. And then I've got negative 4 plus 3 is negative 1, and 6 plus 8 is 14, so I got negative x plus 14 over 7. Or, and there's lots of ways to write this. I probably would have written it as 14 minus x over 7, but the way the answers were in the book we were using, that I got these out of it, they just pulled the minus sign out. So they could put the x minus 14, the x in front, and then these are the restrictions on the domain. I can't have x equal negative 2, or I'd have a 0 here. I can't have x equal 2, or I'd have a 0 there. Okay? So let me just, remember, you can always pause these, rewind them, take a look at them. So hopefully these were pretty straightforward. And I hope that helps.